Good evening. We looked at parametric curves on Wednesday. Right now we're going to look at the calculus of parametric curves. Starting with the slope. Now let's say we're given some weird path. See if t is x of t comma y of t. Right, say we want the slope at that point. We call it x naught, y naught. Well, we know what the slope would be. And it's given by dy dx, isn't it? It's the slope of a tangent line. So it'd be dy dx, and then evaluate at the point. Well, we need to find a formula for dy dx first. And as it turns out, that formula is not too difficult. It's dy dt over dx dt. Or shorthand y dot over x dot. In physics, that dot notation just means derivative with respect to time. So let's say then slope at our point x naught, y naught. It would be dy dx evaluated at t naught. Right? T naught is the parameter that corresponds to that point. Right, because remember, give me an excuse to use this. That dy dx, right? That's a function of t. Because dy dt and dx dt are both going to be functions of t, aren't they? But why stop there? We can, in theory, find higher order derivatives as well. Remember, that is derivative with respect to x of dy dx. Which turns out to be quite a pain. There is a formula. I believe I've derived it. If not, I think it's left as an exercise. X dot y double dot minus y dot x double dot all over x dot squared. Quotient rule. Well, that kind of looks like the derivative of dy dx with respect to time. And I leave it to you to see if there are formulas for the third derivative, fourth derivative, so on and so forth. So we're going to be asked to find dy dx and d squared y dx squared. So first and second derivatives of y with respect to x. And so first dy dx. Right. That term, the 1 minus sine of t, what coordinate is that?
You mean like x or y?
Yeah.
Okay.
Which means that 1 minus cosine would have to be y of t. Right? Just keep that in mind. Right? It's always x comma y. Remember, it's y dot over x dot. So what is the derivative of y with respect to t? What is dy dt? What's y?
One minus the sine t.
So what's its derivative?
Sine t.
Just sine t, isn't it? What is dx dt?
Is it 1 minus cosine t? 1 plus cosine?
It's not fair to ask me. Are you saying that is the answer?
I don't know.
So what'd you say it was? 1 minus cosine?
Mhm.
And you're not sure? Should be. Have more confidence. There's dy dx. Second derivative. So we know x dot. Now, what is the second derivative of y?
Cosine.
We know y dot. What is the second derivative of x?
Sine.
Said sine?
Yep.
Now, x dot squared. Now we just got to simplify it. Well, let's not expand out the denominator. What does that simplify to?
1.
It's not positive 1.
Negative.
It'd be negative 1. Yeah, because it's minus cosine squared minus sine squared. And we have cosine t minus 1 in the numerator. We have 1 minus cosine t all squared in the denominator. Well, can't I factor out a negative 1 from the numerator? Be 1 minus cosine t all over 1 minus cosine t squared, negative, right? And that would simplify to negative 1 over 1 minus cosine. Or 1 over cosine minus 1. dy dx. Y dot over x dot. What's y dot?
Is it e to the power of t?
Just e to the power of t?
No, I'm asking is it t?
Those are all t's, yeah.
E to the power of t cosine t.
That's it.
Minus. And then it's going to be the opposite. Like the rate of e over cosine t.
You said minus?
Or plus.
Right, remember product rule? Second times derivative of the first plus first times derivative of the second. Order doesn't matter. Let me actually keep working with the numerator for right now, just to factor out that e to the t. What about x dot?
t cosine t minus e to the t sine t.
Again, factor out that e to the t. Oh, that's a bummer.
Why do we have a plus in the first case but minus second?
So what's the derivative of cosine?
Okay.
So that would just be dy dx. Ah, okay. Can't read my own writing. That's supposed to be a cubed, not squared. Of course means none of this is going to work. Thought that seemed too simple. So just slight change. This is cubed. This is cubed. That's cubed, which means this becomes cubed. That's going to become squared. I sadly can't get rid of that negative. Which also unfortunately means there's no nice easy way to do this one. All right, well, we know what x dot is. We now need y double dot. Oh, that sucks. We are going to have an e to the t times something. Right. So that times something will be what? That term plus the derivative of that term. So what is the derivative of cosine t plus sine t?
Cosine t minus sine t.
It'd be cosine minus sine, right? So we're going to wind up with a sine minus sine, which is 0, and a 2 cosine. So the second derivative would be e to the t times 2 cosine t, or 2e to the t cosine t. Minus now y dot times the derivative of x dot. All right, again, we're going to have an e to the t common that we can factor out. Again, now we're looking at, what did I say y dot? I meant x double dot. This term plus its derivative. What is the derivative of that term?
Negative sine t minus cosine t.
Negative sine minus cosine. Cosine minus cosine is gone. You're left with negative 2 sine. And then all over x dot, which was that, cubed. Time for some algebra. I'm going to actually go ahead and copy that whole thing.
Can we factor out e squared t?
No, be careful, not e squared t.
Or e squared?
E of t squared,
Yeah.
which would be e to the 2t. Well, not just that. We can also factor out a 2, can't we? Then we're going to be left with, if we look at this first term, just cosine distributed through, right? Cosine squared minus cosine times sine. That's the first term. Notice that this minus is going to become a plus, right? Because we have that negative. all over. Now let's distribute that cubed through in the denominator because it's a product. And write it that way. E to the 2t over e to the 3t. You're left with 1 over e to the t, right? Now the question is, how does this entire sum, how does that whole thing simplify?
Just one.
It's just 1. So 2 over e to the t times the quantity of cosine t minus sine t cubed, right? That's how that would fully simplify. Let's see if that's right. Let's define x of t. What did we say it was? It was e to the t times cosine. Okay, this one's going to be x dot times second derivative of y minus y times second derivative of x over x of t cubed, and I already know there's going to be a problem. I'm going to do full simplify on both of them. And that should not be x of t, right? This should be dx of t with respect to t. Do those match what we got? Hmm? Oh, good, we did our algebra right. That's nice. We did our calculus right, too. So equation of a tangent line to the curve given by that parametrization, root t comma t minus 1 over root t, at the point where t is equal to 4. Then plot the curve and tangent line on the same axis. Actually, before I do that, what's the equation for a tangent line, do you remember? Just have to make a few slight adjustments to this. Right? Instead of x equals x naught, right, we're doing t equals t naught. We're still gonna have y equals. But this f prime dy dx evaluated at t naught. This x naught I should have room. x of t naught. And then this f of x naught would become y of t naught. So I want to clean it up. So this is how we could write the equation of a tangent line given a parametric curve. Which means we need to find that first. That's the slope. What is y dot? So derivative of y with respect to t.
One plus t to the power 3/2/2.
Close.
Plus t to the negative 3/2 over.
Should be t to the minus 3/2 over 2. Or 1 over 2t to the 3/2. What is x dot?
One half t to the negative 1/2.
Right? 1 over 2t to the half. Right, that's going to be evaluated at t equals 4. So I'm not going to worry about simplifying it. I'm just going to plug in 4 and then simplify. 1 plus, what is t to the 3/2 power? Or not t, I'm sorry. 4 to the 3/2 power.
Eight.
It's 8 times 2, 16. Numerator becomes 1 plus 16th over 1/4, right? Multiply numerator and denominator by 16. Get 17 over 4, don't you? So there's the slope. So our tangent line y equals slope times x minus x evaluated at 4. I'll just write it that way. Plus y evaluated when t is equal to 4. So 17 over 4x square root of 4 is 2. 4 minus a half. 15 halves. Negative 17 halves plus 15 halves. Minus 1. Is that right? All right, 4 minus a half. No, that's not 15 halves. That's 7 halves, isn't it? Ooh, my mental math is not good today. So 17 halves minus 7 or plus 7 halves is negative 10 halves. So minus 5. That's our tangent line. And so to find our curve, it's a parametric curve, so we're using parametric plot. T was root, or x was root t. Y was t minus 1 over root t. T goes from, let's do 0 to 8. Let's see how that looks. Oh, we can't use 0. Actually, I probably can. I don't know if it's going to give me an error. Probably will give me an error. We'll see. I'm going to be safe and put the x and y in quotations because I do have x and y already defined. Let me actually, I think it will let me do a space, which is nice. Tan line. He said 17x. Oh. That's not good. Clear. It's not clear what I want. Clear. X comma y. There we go. I don't need those in quotations anymore, but I don't care. We said it was -5, right? What do we want x to go from? Zero to √8. Right, because if t goes from 0 to 8, right there, x goes from √0 to √8. 0 to 8. Plot style. What color do I want to make the tangent line? Let's go pink. I don't need to do this, but I'll just turn the axes off. Yeah, it did fail. Let's make that 1 to 8. No. I'm going to make it so ridiculously small. And so apparently I have to do oh, duh. Oof. That looks awful. And that really is just hideous. So what if I only go out to 5 for t? That didn't really help, did it? I don't know how I'm going to make that look better. I don't know if I can make that look any better, to be honest. I could shrink the tangent line. Say tangent line goes from root 3 to root 5. Yeah, but then we still get that hideous thing. I suppose I could zoom in. Let's see, even that still doesn't really make it look any better. I have to set the, at that point though, I have to set the axis origin to be 0, 0. There's no getting around it. This is just going to be awful no matter what I do. Oh joy. But we get the idea. Not a nice curve to work with. Can you just, thank you. Position of a particle moving along a curve is given at time t. Yeah, English much. Okay, let's fix that. A position of a particle that is moving along a curve at time t is given by there we go, that's better English. Position of a particle that is moving along a curve at time t is given by c of t 2 minus 3 cosine of t, 3 plus 2 sine of t. Coordinates are measured in feet. Time is measured in seconds. I want to find three things. The time rate of change of x when time is pi over 3. Time rate of change of y when t is 5 pi over 3. And the time rate of change of the angle of inclination of the tangent line when t is 2 pi over 3. Right, so there's a path that our particle is following. Part A, they want time rate of change of x when t is pi over 3. So what are we looking for? Right, so if we're looking for time rate of change of x, what are we trying to find? Overthinking it.
Yeah, so for dt.
Just x dot, isn't it? He wanted at pi over 3, right? So x dot at pi over 3. So what is x dot? What is the derivative of x?
Three sine.
Three sine of t, evaluate that when t is pi over 3. What's sine of pi over 3?
Square root of 3 over 2.
And what are the units?
3.
Feet per second. Units of x per units of t. Time rate of change of y. Well, that shouldn't be difficult to determine what we're looking for, right? Y dot, isn't it? This time, though, when t is 5 pi over 3 seconds. What is y dot?
Two cosine t.
All right, we're going to get 2 cosine 5 pi over 3. What is 5 pi over 3? Cosine of 5 pi over 3.
Can you minus square root of 3 over 2?
Here's what I do, trig. What's cosine of pi over 3?
Over 2.
What is it?
1 over 2.
What quadrant does 5 pi over 3 lie in?
First.
Second.
5 pi over 3.
Oh, 5. 4.
Fourth quadrant. Is cosine positive or negative in the fourth quadrant?
5.
Pi over 3 is a reference angle for 5 pi over 3. So that means cosine of 5 pi over 3 is 1/2. It's the positive of cosine pi over 3. All right, that's the easiest way to do the trig functions. So we get 1 foot per second. This one's fun. Time rate of change of the angle of inclination of the tangent line when t is 2 pi over 3. I don't know, say we're given some curve. Let's make the curve a little bit better. That should work. Now we're given some curve, C of t. Right, say that is our point t naught. That would be our tangent line at t naught, right? Which, keep in mind, is the same thing as that ordered pair. Right, they mean the same thing. Angle of inclination. Is that angle right there. But remember, how you draw your coordinate system doesn't matter. So I can essentially just look at the tangent line at that point. Now make that point the origin. Then I can think of this as kind of like right triangle trigonometry. as green. Yeah, I'm going to do right triangle trigonometry. This is the tangent line. Right, the hypotenuse acts as our tangent line. This distance here would be x prime of t naught. Right, it's the distance from the origin to that point if I'm moving the coordinate system. That'd be y prime of t naught. Don't care what the length is. Don't care what the length of that tangent line is. Right? That length is going to scale. What trig functions depend on the base and the height? In other words, if this is our angle, what trig functions depend on adjacent and opposite?
Sine.
Tangent.
Tangent. Which other one?
Tangent.
Cotangent. It doesn't matter which one you use. However, it's customary to use the tangent function. So I can hide the ruler. Tangent of theta equals be y prime of t naught over x prime of t naught, right? And let's call that theta naught to represent it's at that specific point, right? Because obviously that theta is going to change if we draw the tangent line at a different point. This, of course, means, first of all, theta is a function of t, right? That angle of inclination is going to change depending on the point. So it does change. It's a function of t. But wait, what's y prime over x prime? Well, I should be using dots, but whatever. I'm going to stick with primes. What's y dot over x dot? That's just dy dx, isn't it? For a tangent line, tangent of its angle of inclination is the slope of the line. Let's call that theta inclination. equals slope. In fact, that's going to be true of any line. Slope is always the tangent of the angle of inclination. So we're going to use that formula. Well, we know what y dot is, right? We know what x dot is. We get tangent of theta is 2/3 cotangent of t. Now use implicit differentiation. Because we want theta dot. What's the derivative of tangent? What is the derivative of tangent? Uh-oh. Oh dear. It's secant squared.
I wanted to see secret something.
And then times obviously derivative of theta. So you get theta dot secant squared of theta. What is the derivative of cotangent? Negative cosecant squared. And by the way, these are all in that table of derivatives that are posted on Teams, which you are allowed to use for the final. I recommend you print it out.
you want to use calculators on the final?
So theta dot would be negative 2/3 cosine squared theta cosecant squared of t. But we want theta dot when t is 2 pi over 3. To be negative 2/3 cosine squared of theta evaluated at t equals 2 pi over 3 times cosecant squared of 2 pi over 3. Oh boy. So we need to know what theta is when t is 2 pi over 3. So let's do it this way. There's theta. We know what tangent of theta should be when t is 2 pi over 3. What is cosine of 2 pi over 3? First off, yeah, we'll do that. What is cosine of 2 pi over 3? Negative a half. Times 2 is negative 1. I'm going to write that down as 1 for right now. What is sine of 2 pi over 3?
Negative √3 over 2.
It's positive √3 over 2. Times 3. What's that going to make? I'm going to write this. Y was less than 0, x was greater than 0. What's that going to make this missing length?
Square root of 1 plus 27 over 4.
Right, so 27 over 4 plus 1 is what?
31 over 4.
31 over 4?
And then square root.
27, yeah. So root 31 over 2, right? This tells me if y is less than 0 and x is greater than 0, theta's in what quadrant? Yes, yes. That's actually going to matter because cosine's being squared. In quadrant 4, cosine is positive. So use this. Based on this information, what is cosine of theta?
Two over square root of 31. Oh no, that's sine. Three square root of 3 over square root of 31.
Square it. Get 27 over 31. That is cosine squared of theta when t is 2 pi over 3. Now we need cosecant of 2 pi over 3. Well, we just said what sine of 2 pi over 3 was. Negative root 3 over 2, right? So 1 over that, negative 2 over root 3 squared. 4/3. So it's going to be negative 2 times 27 times 4 over 3 times 31 times 3. It's going to be 8/9 times 27 over 31.
24 over 31.
Should simplify down to negative 24 over 31. And what are the units? Radians per second. There's a reason why I don't solve for theta here. Remember, the inverse tangent function has a range of minus pi over 2 to positive pi over 2 open. That's only half of your possibilities. This is the safest way to examine this type of problem. We're going to get some free math today. Actually, we'll go until 10 of. because we still need to look at arc length. Right, so again, little s is typically what's used. I always like L for length, doesn't matter. It's the integral from a to b of the square root of x dot squared plus y dot squared dt. I'm also going to give surface area because I don't have a problem with surface area. All right, so capital S or A, integral from a to b of y times the square root x dot squared plus y dot squared dt. And the beautiful thing about this is if it's now rotated about the y-axis instead, there's only one change to the formula. That y becomes x. Okay, so real quick. Length of this curve over the interval 0 to 4. This is probably all I'm going to have time for. Length. Integral from 0 to 4 of the square root of x dot squared plus y dot squared dt. Over 0 to 4, t is going to be positive. So you can factor out square root of t squared, which is just positive t on that interval. Derivative of 4 plus 9t squared is 18t, right? We don't have an 18t. We do have a t, though. So multiply by 1/18. Right? Antiderivative u to the 1/2, 2/3 u to the 3/2. One over 27 times, 1 over 27. All right, when t is 4, 9 times 16. Too lazy to do that in my head. 4 plus 9 times 16 is 148. That's 148 to the 3/2 minus 4 to the 3/2. What's the square root of 148? Square root of 148 is 2 root 7, or 2 root 37. And then 2 times 148 is 296. 4 to the 3/2 we know is 8. And I believe 296 is divisible by 8. It is. That's the arc length. I'll leave you to verify on your own that the arc length of this is 8. Right, so that's for you to do. Questions on what we did tonight? This is the last quiz. That's exciting. So we do Wednesday. At this point, you can actually now work on assignment 23. So the next week, we just look at polar coordinates. Final exam is next Wednesday. See you again on Wednesday evening.